Hey, how's it going out there, everybody? Welcome back to another lesson in Algebra 2. We are in Unit 1, the foundations of algebra, and we're going to go right into Lesson 6 today, manipulating formulas. So, in math, the further we go in math and science, the less numbers we have in our equations and the more variables. So, it's going to be really important moving forward that you are able to take equations that are full of variables and solve for whichever variable you want without having to have numbers in them. So, that being said, let's get right to it. Okay, I'm going to start with the formula for area of a triangle, 1/2 base times height, and let's solve it for the base b. So, I'll put a equals 1/2 base times height. And I think you know what to do here. We're going to get rid of that pesky little fraction by multiplying both sides by the denominator. The denominator is 2. So I'm multiplying both sides by 2. And I get 2a. And I have to multiply 2 to one of these three things. So I'll multiply it to the half. 2 divided by 2 is 1. 1 times 1 is 1. And then 1 times anything is itself. B, h. We're asked to solve for b, so at this time I will divide both sides by h, and I get 2a over h is equal to b. We have solved the equation for b. Let's try the height. I'll start again with the original equation. Should have a very similar first step, right? But it's good practice. Okay, we're going to multiply both sides by 2. And that's going to give me 2a. The 1/2 and the 2 become 1, and then it's just b h. All right, now I'm going to divide both sides by b so that I can get h. So this is 2a over b is equal to h. Okay, I think now you have some practice problems to do. You should know the drill by now. Pause the video, work practice 6.1, and then we will get back together and check your work. So pause the video and give it a shot. Okay, welcome back. Let's see how you did. All right, we have distance traveled. Distance is equal to the rate times the time. Let's solve it for the value r. D is equal to rt. Solving it for r, so I'll divide both sides by t. So distance divided by time is equal to rate. Pretty good, right? Let's try the next one. Let's solve this one for the time t. So I have distance equals rate times time, and I'm going to solve it for time t. I'll divide both sides by r. Perfect. Okay, hopefully you didn't have too much trouble with that one. All right, let's take a look at this next equation here. All right, this formula is, well, it's almost the formula for area of a trapezoid. It is missing one little letter. It's missing the H, but I think this one will just be plenty difficult enough to isolate. And so maybe it's some weird trapezoid that doesn't have a height. I don't know. But let's take a look at solving this for b sub 2. All right, I think I will multiply both sides by 2, giving me 2a. And the 1/2 and the 2 reduce. And then do I really need the parentheses if there's nothing but a 1? Because 2 times 1/2 is 1. And 1 times anything is itself. So I think the answer is no, I don't anymore. Okay, and now I'm solving for b2, so I'll just subtract b1 from each side. So 2a and b1, these are not like terms. They are not combinable. So we just have to write that because they don't have the same variable, the same power. Now, please don't let these subscripts confuse you. It's just indicating that I have two different variables that are called b. I have b sub 1 and b sub 2. They're not exponents. They don't do anything. They don't multiply to them. There's just a way of indicating that we have two different things that have a variable b. You could have 100. You could have x1, x2, x3, all the way up to x100. Each one of those is, as long as they're subscripts, are basically just different letters. Okay, I want you to try the next one. So pause the video and give it a shot. Okay, well, welcome back. Let's see what we can do here. I've got v is equal to pi r squared plus pi r l. Well, no, that's not a correct formula either. That would be something kind of similar to the volume of a cone, but I've changed the formula up a little bit. You can tell I was just kind of making these up, huh? But that's okay. Let's solve this for L by subtracting. Let's subtract pi r squared from each side. Yeah, I think this is actually the area of a cone, if you want to be exact. But, I'm not teaching geometry. V minus pi r squared equals pi r L. And I make my L's like that so they don't look like a 1. Okay, so now what do? Well, we need to divide by pi, but we also need to divide by r. So I'm just going to do it at the same time. So I get v minus pi r squared over pi r. And for the love of Pete, do not cancel these out. No. You would have to have pi's in every single term. Terms are separated by pluses or minuses, so I'd have to have a pi with the v. I have a pi with that r. I have a pi with that r. I don't have a pi everywhere. Maybe you want to cancel r. No. You'd have to have an r with every term. I'd have an r here, here, and here. Guess what we're going to do? Absolutely nothing. We're going to stop right there and call that one done. Okay. Let's try another one. It's an algebra formula, so maybe I got the formula correct. We'll see. I think I did. All right, so I want you to solve this for x, not to be confused with x sub 1. With this particular formula, x sub 1 and y sub 1 are constants, and then x is a variable. So it's kind of weird the difference between a variable and a constant, but it turns out a constant can be a letter because it could be an unknown constant, whereas the x and y are set to vary. I don't know if that interests you or not, but whatever it is, I want you to solve it for x. So pause the video and do it. Okay, let's see how you did. All right, solving for x. So I got y minus y1, and this is, so what did you do here? Did you distribute or did you divide both sides by m? You could divide both sides by m first. It'd be a little bit different story, wouldn't it? I'll distribute, and I'll tell you what, I'll do it this way, and then for those of you out there that did it a different way and want to check that result, we will go over that. So solving for x, so I need to add an mx1 to both sides. So I get y minus y1 plus m times x1 equals mx. I'll divide both sides by m, and I get y minus y1 plus mx1 all over m equals x. Question: can I cancel that m with that m? No. I'd have to have an m in every single term. All right. So that is, I'm going to call that method 1. Let's see what would happen, and I will use a green marker this time. Let's see what would happen if you did this problem a little bit differently. All right, so you could divide both sides by m right off the bat because this is m times something. And I would get y minus y1 all over m equals x, because the m's will now reduce, minus x1. Solving for x, so I'll add x sub 1 to each side. And I get y minus y sub 1 over m plus x sub 1 equals x. And obviously those two things are exactly the same, right? Well, maybe not so obvious, I know. But they are, because if I were to group these with the associative property of addition, I could then divide both sides of this equation and call this y minus y1 over m plus mx1 over m. And then I do have an m in every term over here, so I can reduce them, giving me that equation over there. But in general, I don't care if you knew how I made them look the same. What I want you to know is that the right answer can appear in different ways. The same formula that does the same thing can look slightly different. So just be aware of that. Okay. Oh, we're going to solve for y now. So moving on to the next example, we're just going to do some good old algebra, because this is our meat and potatoes, solving equations for y. Why do we solve equations for y? Well, we're going there soon. We're going to talk about functions. And we typically, in this class, will represent y as a function of x. So in order to do that, we have to solve for y. So it's a good thing for us to brush up on right now, because we're going to use it big time when we hit functions in the next unit. So here we are with 3x minus 4y equals 10. Let's solve for y. I will subtract 3x. So I have negative 4y is equal to 10 minus 3x. Now, I can't combine them, okay? I got a 10 and a minus 3x. They're not like terms. This one doesn't have an x, this one does. So I can either write 10 minus 3x, or I can write minus 3x plus 10. You do it either way. I prefer to have x's in front of things that are not x's, right? So that's just me personally. Now I'll divide both sides by negative 4. So I get y is equal to negative 3x plus 10 all over negative 4. Then from here, we could divide each one of these terms by negative 4, but I'm going to go ahead and stop there. Just a couple of things to point out. Notice we're back to having a lot more numbers, but we still have two variables, x and y. And therefore, I'm not going to get a single number result for y most of the time, unless for some reason our x is completely canceled out. For the most part, if you have x and y in an equation, don't expect to get an answer for solving for y where it's a single number. It's just not going to happen very often. All right, let's go on to letter B. 2xy plus 7y equals 10. And we're solving for y. Okay, so when you're solving an equation for y, what you want to do is get all the terms that have a y in it on the same side of the equal sign. Okay? And I've got that, right? I've got a 2xy and a 7y. Those are the two terms. Remember, terms are separated by pluses and minuses. So I've got this term, that's a term. I've got this term, that's a term. And I've got this term, right? I got the ones with y's on one side. Now, what I want to do is I want to factor out that y that's in common. So let's do that. I'm going to use the distributive property. Maybe you think of this as factoring, but we'll talk about factoring later. But that's the distributive property backwards. You're probably used to distributing y here and here, but I'm pulling it out. Some of you might be wondering, why is there only one y when there were two y's before? But remember, when you distribute, this y would go to both of these things, right? It would go there, and then it would go there, giving me back 2xy plus 7y. So when you pull something out and use the distributive property backwards, don't be surprised to have to write the letter y less often. Okay? That's just kind of how that works. All right, now I've still got a 10 over here, but look what I've got. I've got y times some junk. Let's divide by that junk, 2x plus 7. And that whole thing, now this division bar is a grouping symbol. If it helps you see it, you can do that. But this whole thing can be reduced now. And I get y is equal to 10 over 2x plus 7. So over here, we can't just divide, say, the 3 by the 4. We'd have to divide the 3 by 4 and the 10 by 4. I'm talking about this one over here now. Okay? But over here, I was able to divide. What's the difference? The difference is these parentheses. The difference is that it's really just one term, because I've got multiplication and parentheses around these whole other things. If I had y times 2x plus 7 and the 2x plus 7 were not in parentheses, I could not divide both sides by 2x plus 7. Would not work. But because they're in parentheses, I can. So kind of, we'll talk a lot about that, but I want you to get that shape in your mind for when you can divide. All right, let's do the next one. Okay, I think we need to distribute. And combine like terms. Okay. I will subtract 5x from each side. Let me give myself a little bit more room here. And I got negative 3y equals, again, I'm going to put the negative 5x in front and the positive one in back. You do it however you want, but that's just, to me, it's too unsettling otherwise. Divide by negative 3. And I get y is equal to negative 5x plus 1 all over negative 3. All right? That's pretty much it for that one. Let's go on to this next one. Okay. Oh, well, I could distribute right now, but I don't think I'm going to. I think I'm going to go ahead and add x to both sides. And I'll get 10 plus x equals 4y times x plus 1. Because I already had that 4y factored out, that's totally good for me. Because now I can divide both sides by x plus 1. Again, y can do it. I mean, I want you to be a little bit tentative when you divide with like multiple things here, right? But look at what we have. We have 4 times y times something else. And then I divide by that something else. So as long as they're all multiplied together, I can do this. But without those parentheses, I would have had a plus not inside parentheses. And once you have a plus sign in the division problem, can't do it, okay? So that's why I can do it, because they're in those parentheses. Okay, so what does that do for me? Oh, you know what, though? I've also got this 4 times y. Can I divide by that as well? Yeah, I can. You just need to put it out in front. So we're going to take care of that as well. That reduces. So that gives me a y on that side, a 10 plus x over a 4 times x plus 1. All right. I got it. Is that the only way to do it? No. You could have distributed, but at some point you were going to factor out that y. Like we did. If you distributed, you'd be doing it more like we did on letter B at some point. So some of those were easier than others. Others were kind of challenging. Take your time. You've got... we got one more practice set, but it's got 5 problems in it. So please go ahead and pause the video at this time. Give it your absolute best try. And when you're ready, unpause and we'll go through it. Okay, well, I hope that wasn't too disastrous. Looks like there's some curveballs. I mean, I think you know me well enough in this video series to know that the practice problems are not always exactly like the ones I did. But that's good. That's an opportunity for you to problem solve. Let's go through and do these. 7x minus y is equal to 12. Okay, this one's not too bad. I'm going to subtract 7x, and maybe you wrote it as 12 minus 7x, but I'm going to write negative 7x plus 12. Now here's the deal. Now you didn't forget this negative, did you? You wouldn't do that, right? Because that negative is tied to that y. And I hope you also subtracted 7x because that's a positive 7x right there, okay? So just be a little careful on those things. All right, so that canceled out. So I need to divide both sides by negative 1. And you know how to divide by negative 1? You change the sign on every single term. Yes, I could leave it like this. That's kind of ugly, though. Let's go ahead and divide through by negative 1. Negative 7x becomes positive 7x. Positive 12 becomes negative 12. And there we have it. Nice and pretty. All right, let's look at letter B. Ooh, what'd you do? Did you try and get rid of the y by multiplying both sides by y right off the get-go? Because that would work. I'm going to do that because that's what I've taught you to do, right? I don't know if it's the fastest thing to do, like as far as like, trying to avoid using up too much ink. Okay, I'm not gonna do that. That's too ugly. I'm gonna write it below. Actually, you know what I'm doing? I'm gonna cheat. I'm gonna erase that little letter B, so I don't have to write it all again. Okay. There we go. So yeah, this is what we said to do, right? We said multiply by that thing on the bottom. This is the first time we've ever had a variable in the denominator, though, right? So is this gonna work? Well, I hope so, but it will. It's no different when it's a y than when it's a number. So y times 3 over y is equal to 3. Okay, I just lied a second ago. Yeah, it is a little different, but I don't want to go. There's a little tiny thing, but we're not going to talk about it today. All right, then y times 2x is minus 2xy. All right, then on the other side of the equal sign, y times 1 is y. Okay, good. Now, what do we do here? I hope that makes sense. I distributed, remember y divided by y is 1, and 1 times 3 is 3, y times 2x is, 2 times x times y, and then, of course, just y on the other side. Earlier, remember I talked about this, get all your terms that have a y on one side of the equal sign. Whatever you're solving for, if you have that letter, that variable in multiple terms, and again, get used to seeing these things as different terms separated by pluses and minuses. I've got two different terms that have a y in it. Get them on the same side first. So I'm going to add 2xy to both sides. Give myself a little bit more room. Hold on. All right, I will just erase it. Okay, so I've got, those are gone, and I got 3 is equal to 2xy plus y. Now, here's what we're going to do. We're going to factor out that y. We're going to use the distributive property backwards. And when I do that, I get a y times 2x plus 1. That's what I'm looking for. I used to have two terms. This is two terms, right, that have a y in it. Believe it or not, this is just one term because it's y times something in parentheses. So once I've done that, I've opened up the right to divide both sides by 2x plus 1. I can divide both sides by 2x plus 1 now because I have them inside those parentheses. I want you thinking about that. Remember that division bar is a grouping symbol. That whole thing can divide. So I have 3 over 2x plus 1 is equal to y. That's my final answer. All right, let's go to this one over here. Hopefully we get a little bit of a break after that brain teaser, right? Okay, I'm subtracting 3 from each side. 10 minus 3 is 7. Let's add x to each side. And I have 2y is equal to x plus 7. I'll divide both sides by 2. Give myself a little bit more room here. And I get y is equal to x plus 7 all over 2. All right, now we have letter D and E still to go. So let me go over there and grab those again. I think I'll just grab them one at a time. I tried to grab too much and got crowdy. Okay, so here we are just with letter D to focus on. Oh, and it's fractions. Okay. Well, wait a minute now. Why should I be upset about there being fractions? Because I don't have to play with these. I have an equal sign. I think you know what to do. We're going to multiply both sides by the smallest number that's divisible by 5 and 4. That's called the least common multiple. Get it? Because a multiple is something you multiply up to. So smallest number divisible by 5 and 4. So let's start with 5. Can you divide 5 by 4? No. All right, next number that 5 multiplies to, 10. Okay. Can you divide 10 by 4? No. 15? Nope. 20? Yes. So there we go. So we want to get 20. So I'm going to multiply by 20 on both sides because that's the smallest number that I can cancel the 5 and the 4 with. If I didn't realize it was 20, I could have gone higher. It just makes my numbers bigger. But as long as that number can be divided by both of those, we're good to go. All right. Now remember, the important rule here is divide first. Whenever you're multiplying fractions by whole numbers, please divide first if you can. 20 divided by 5 is 4. 4 times 2 is 8. 8x. Good. 20 divided by 4 is 5. 5 times 1 is 1. Excuse me. 20 divided by 4 is 5. 5 times 1 is 5. So I have 5y. On the other side, 3 times 2 is 6, so 3 times 20 is 60. And now let's solve for y. I'll subtract 8x from both sides. I have a negative 8x plus 60. And again, you could write 60 minus 8x. It's not going to hurt my feelings. Okay, divide both sides by a negative 5. I get y is equal to negative 8x plus 60 all over a negative 5. All right. One more to go, right? Here we go. Oh, and it would happen to be one of those that's got multiple letter Y's in it, doesn't it? I think it's okay. I think we know what this is going to do. We got to get all the terms that have a Y in it on the same side of the equal sign. Okay, check. That's already done for me, so I'm good there. Factor out a Y. This is the distributive property backwards. Oh, but what goes there? Well, I need something here that when I distribute this y, I have to get back the original. That's how you would check, right? You know, if I have 8 plus 4, I can say, well, that's 2 times 4 plus 2. How do I check that? I multiply back and make sure that I get the same thing, right? I would get 8 plus 4. So I'm always thinking when I do this factoring, I'm always thinking make sure that whatever I get here, if I multiply the y back through, it would take me back to the original problem. So y times what is y? Well, that's 1. Did you forget and make it like minus nothing? No, that wouldn't be good, right? Because remember, when you distribute, you have to get back the original. Y times 3x, 3xy. Y times 1 minus y. So that's really important. Another explanation is that when we factor this out, we're actually dividing each term by the variable y. So y divided by itself is 1. So that's another way to think about that. Okay, and then I have just a 4 here. All right, I'm going to divide both sides by 3x minus 1. That reduces because the whole thing's in parentheses. We know that's so important or else I can't do the division. Those are in parentheses automatically because the division bar does that. And I have 4 over 3x minus 1, and we don't do anything else beyond that. That's the end of our lesson today. I want you please to go ahead and check out this lesson's exit ticket, something to contemplate. I want you to look up the surface area of a right cylinder, manipulate the equation, and see if you can answer those different values and kind of experience using the benefit of a manipulated equation. I'll leave that to you, and until next time, take care.